Math 140, week number 5. We have a midterm coming next week. Let's make sure we understand everything that you can be prepared for on the test with this little review homework. I know it's a little different than some of the stuff we've done in acrobatics, so let's walk through it. Number 1, we got a bar chart, histogram, analysis questions. Well, I'll switch up the chart on you a little bit, but I'll walk through the same process. The main thing in order to get through this is that hint that I gave you, rewrite things in the table. So if I give you this chart, I'm looking for a table, or I think that's one of the easiest ways to approach this problem. When I'm making the table here, you need to find ages and the frequencies. Well, so when I'm saying ages, take the first bar. Say the first bar is 20, but I go 20 to 24. Where's the 24? That's right. The next bar is at 25. So we go up to 29 a third. You're running away with it from there. You see the process. Frequency means how many means, look at the first bar. It's about 3 tall. I think you know why I'm not using decimals or anything like that in this scenario. Second bar, same thing, about 3. Look at the other bars, play the same game. You've done it. Graph to table. Critical first step, or at the very least, it's going to make your life easier when you go back to the questions. So if I'm asking below age 50, it's easy with the chart. Or with the table here, I just look at all the numbers below 50, and I can add them up, and then take a percentage from there. Part B, you do not need necessarily a table for this one. You just need to understand the shapes. If I say symmetric, up and down, looks pretty balanced. Right skewed, it's up and down, but there's this tail on the right-hand side. Left skewed, same scenario, but there's a tail on the left-hand side. Those 3 charts, your graph should match one of those, roughly speaking. It's like a multiple choice. It's basically saying, hey, here's my data. Here's the one I believe it is. Last one, median age. Median means middle, means take all the numbers. How many people am I measuring? In this case, I'm measuring 54. The middle of 54 would be about 27 to 28 people, roughly that. All right, so who's the 27th? Who's the 28th person? We'll just go up the line. Say there's 3 people here. 3 plus 3 is 6, plus 5 is what? 11. Plus 7 is 18. Keep going that process, and eventually you'll get to that number, and you'll say, hey, here's my median. This is where the middle of my data is. Follow those steps. You'll be able to solve number 1, but the critical step, graph to table. Number 2, I'm going to breeze through this one. You more questions, you email me, but look there's a number here. There's a percent here. There's a number, percent, number. And I'm asking you total people, use those numbers. Percentage of people, use those percents. Real straightforward, get the numbers from the graph. If you have any questions, let me know. Number 3, we have not done this one, so I want to really focus on this one. When you see empirical rule, this is a different process. So plug in, hopefully this makes sense. Let's go through it. You're solving for women. I'm making up numbers, so I'm going to make up Martians. Sure, great. But the main thing, forget the scenario, focus on that word. Normally distributed. Normally distributed means the data looks like this. We've seen that. It's a bell curve. It means most people are in the middle. Some people are really high. Some people are really low. Makes sense. That's how a lot of the world is organized, really, right? Most people are average, so to speak. What we need to do is we need to label this graph, and this empirical rule will tell us some percentages. So the first step is on us. We need to label. How? Well, label the graph. The mean is the middle. That's easy. Standard deviation, well, that's a little tricky, but standard deviation means how much do I go up or how much do I go down. Using that process, we can label this graph. And you see, I haven't even used the whole bell curve. Let's go again. Always by 30, always by the deviation, plus and minus. Another 30. Let's do it. Why not? That is on you. That's the mathematical part of this, is to label the graph. The empirical rule, that gives you percentages. And I'm going to throw some percentages at you, and you're going to say, well, where did those come from? And I'll shrug my shoulders and say, that's the rule. The numbers down here, that's on you. The rule, you're just going to know that in these middle groups, the biggest groups, 34 on that side, 34% of the people live in those groups. In the next biggest groups, a little smaller, but 13.5% of the people live in those groups. And the last little groups way down the line, little tiny ones, 2.35% of people live in those groups. So those percentages that I'm telling you right here, the red boxes, you got to memorize those. Put those numbers down, scribble them down, whatever. That's the empirical rule. The numbers on the bottom, that's on you to solve using the given problem. But once I have those once I have those percentages from the empirical rule, how do I apply it? Well, read the problem. Between 370 and 460. I identify those. There's 370, there's 460, which means that those percentages are in between, which means add them up, and then you could find the answer to part A. use that same process to get part B and other questions using the empirical rule. So one more time, percentages, that's given, but the numbers on the bottom, that's on you. Number 4, here I'm talking about box plots. All right, so this box plot represents the number of people, or the length of time people took to take a math test. Well, that's your problem. I'm going to solve it for, hey, make up some numbers. Pretend I measured people eating a whole box of Oreos, and I graphed it, and I got this thing. Could I analyze it? Sure enough. Why not? First thing I'm going to do is call it a 5-number summary. Say, take those numbers. Those numbers represent the I'll let it play out. Those are the 5-number summary numbers. So the minimum, I can just look at those numbers, and I can find the minimum. I can look at these numbers, and I can find the maximum, quartile, all those sort of things. So given that graph, you can find the minimum, first quartile, median, third quartile, and maximum. Next up, second quartile, just follow the pattern. First quartile, median, third quartile. I think you can think of another name for the median in the middle there. More than 3 hours. How would I answer that? Well, you know what the maximum is, so then you can answer this question. You know what the maximum number is based on that 5-number summary, so you can find if that's more than 3 hours or not. Interquartile range, that is between the first and third quartile. So just you have to do a subtraction. How many numbers are between those two numbers? Range is a fancy word for maximum minus minimum. And then the last one down here, when I say 50%, you know what? Those percents kind of remind me of that empirical rule we were just doing, right? Well, the thing about the box plot is it's sort of like empirical rule, except it's the percents are very, how do I describe it, uninteresting. I know that 25% live between those numbers, 25% live between those, 25 behind those numbers, and so on. You can take that reasoning and then answer these questions right here. I'm talking about Oreos. I think you're doing math exams, but it's the same concept. All right, that is a very quick walkthrough of the first 4 questions. The last 4, that's video number 2, and that's coming soon. But if you're processing through this and saying, I just don't get number 1, 2, 3, whatever, you're going to shoot me an email, and we'll take it from there. So first step in this midterm review, video number 2, we'll get that up tomorrow.